Well, hello everyone, and welcome back to our fourth session on the CCDA course. For those just joining us, my name is Jean-Claude Lefebvre. I'll be your instructor throughout this class. This section is about addressing and routing protocols in an existing network. So, the concept of a scalable addressing. So we'll be looking through routing and addressing schema and how we apply those to a sound design. Keep in mind that within the CCDA, the prerequisite is a completed CCNA, routing and switching at least, or any other similar CCNA, and that any CCIE can act as a prerequisite also. So within the first part, we'll just do a small recap, go through what's and how IPv4 address works, so that later on it makes sense when we apply this to a design. So any IPv4 address is 32-bit long, so if we were to convert the dotted decimal representation, we would see them as 4 different octets, so 4 8-byte long numbers. So the dotted decimal representation is composed of octets that are 8 bits long. So if we were to divide 32 by 8, we would have 4 octets, and then each octets are represented in decimal, and the value would be between 0 and 256. So if we were to convert the binary on top here, we would get this dotted decimal, which is 110.50.242.10. So how do we convert this? And this slide I really like, and this is something personally I do every time I sit at a networking exam. This is one of my tricks. If you do your exam at a Pearson site, they always hand you this nice sheet and a erasable pen. So as soon as you sit down and you're okay to begin, what I do personally, I write down my conversion, my binary conversion, which is 128.64.32.16.8.421. If you look at the top here, this would represent your binary number, your octet here on the top. So 8 numbers and the value of each octets. Why I do this? I know them by heart, but I find it very useful with an exam. You're not wasting time. Sometimes you're a bit nervous, so at least it's always handy. So how do we do this? Well, what you do is you look at your chart and you start from the number on the left. So it would be 0, 0, then it would be 64, 32, 0. This number is 8, 4, 2, and 10. You add them up, gives you the number 110. So that's how you convert from this chart, by putting your binary number on just below your chart, and that would give you your number. So 110 is the value of our first octet in decimal. If we were to convert each octet, it would produce 4 decimal number. Then we separate them with a dot, hence the dotted decimal notation. So when you look at an IP address, it's a dotted decimal representation. That's not a decimal number, because each number are a representation of a byte.